Everybody. My name is Pedram Naveed. I'm the head of data engineering here at Dagster Labs, and I'm super excited today to talk to you all about Dagster SDF and the evolution of our data platform. I've got the SDF crew here as well. Lucas, you want to introduce yourself maybe?
Yeah. Hey, I'm Lucas, one of the co-founders and the CEO of SDF Labs, building a next generation transformation layer and database engine called SDF.
All right, sweet. So we'll cover just a few things here before we get to our big demo. We're going to talk about the topic and motivation of this little webinar we have together. We're going to introduce SDF, do a quick refresher on Dagster for those of you who aren't familiar with it, talk about how SDF and Dagster are going to help bring data harmony to everyone, which is great. Do a demo, which I think you'll all be very excited about, and then follow that up with some Q&A. For those of you not in our Dagster Slack, you can click on that link, look at that QR code, and it'll take you to the Slack community where we have a Dagster deep dive channel. Feel free to hang out there after the talk. We'll also be there so we can help answer questions if you don't get to them within the webinar.
Cool. So yeah, maybe I can get started and talk a little bit about the SDF and Dagster integration and why the SDF team and the Dagster team were really excited to sort of put this together over the last few months. SDF is a transformation layer that has a deep semantic understanding of SQL. So we understand SQL types and dependencies, and SDF packages all of that metadata up into an information schema, and they can hand that metadata to an orchestration layer like Dagster to provide more insights and more correctness before you ever actually get to executing. What that means is that the offline world of local development and the online world of orchestration can work together a lot more seamlessly than they have in the past. And then once you have that capability, we get to do some really clever things in terms of caching and materialization to make sure that really only the assets that you need or that have changed need to be rematerialized. So maybe talking a little bit about SDF and why we have built SDF in the way that we have. We all know SQL is the most widely used language for querying, managing, and transforming data. But SQL is not all the same, right? Snowflake SQL is different than Trino, is different than Redshift, is different than BigQuery SQL. And obviously that leads to things like vendor lock-in, but crucially, it also makes it really hard to build great developer tooling, right? Because you might build, if you want to try and build a really great, Snowflake transformation layer, you have to exclusively connect to Snowflake. Because the only people that have a true Snowflake compiler is Snowflake themselves. So if you want to catch something as simple as a syntax error, you have to send a query all the way to Snowflake, wait for Snowflake to give you a response. And this is actually kind of debilitating from a developer experience. And it's very different than software, right? Where you can write, TypeScript, validate it locally, send it to Heroku, send it to AWS, and it should run the same no matter where. And this online development world results in, I think, slow iteration. If you've ever worked with Jinja, there's a lot of indirection that happens, right? Where you have some raw SQL with some Jinja templates over here. You have some compiled SQL. You send the compiled SQL back. Snowflake says, hey, there's an error on line 67. What does that actually mean? You kind of have to reverse engineer where the thing actually came from. And this indirection is tough from a developer experience standpoint, but it's also very expensive from a total cost of ownership standpoint because you keep having to send and execute queries on Snowflake all the time. So this now gets into SDF and why we've built SDF the way that we have and what SDF actually is. Sorry, this poll just popped up. So SDF is a true SQL compiler. So SDF will take a SQL statement and build a fully qualified logical plan that we can analyze. Means that you can develop SQL locally without needing to execute queries against the data warehouse with full confidence that when you send them to that data warehouse, they will execute successfully. Because SDF is a compiler not just of a single query, but of many queries at the same time. We can also generate really great things like column level lineage, We can integrate native data classifiers, right, or what we call the type system for SQL. It's all really exciting stuff that I won't get into too much detail here because I really want to talk about the Dagster integration. And then because SDF generates a fully qualified logical plan, we can, in a lot of cases, actually execute that logical plan. What that means is that SDF is not just a transformation layer, but also a pretty full-featured, fast in-process execution engine that is powered by data fusion. So you can write queries with SDF as a transformation layer and execute queries with SDF as a database at the same time. And from a developer loop process, this changes things pretty dramatically when compared to something like DBT. So in DBT, when you write a query, DBT does the pre-processing. It expands Jinja, goes through refs and configurations, and then you have some query string that you send to your Cloud DB. But whether or not that query is actually valid, we don't know at the time that we send it to Snowflake, right? We kind of have to wait for the query to come back. And then Snowflake or the Cloud DB reports the error and the result. On the SDF side, this changes pretty dramatically because all of a sudden you can compile and actually validate or even run the query locally before sending it to the Cloud DB. And you can validate that the query is actually correct before you send it to the cloud database. And that means that iteration time as a developer is dramatically faster. Cool. I'll pause here. This is sort of the quick introduction to SDF. There's more information on our in our docs. Feel free to download it, try it for yourself. But now it's time to talk about orchestration layers and how SDF as a transformation layer can actually really, I think, superpower some of the really great work that Dagster has already done. So yeah, Peter.
All right, thank you. And just an aside, yesterday I was doing some front-end development, and it was so fast and so easy to know as soon as I did something wrong. And I was dreading going back to data engineering. So the more we can make data engineering more like front-end development, the happier I think I will be, at least. So really excited by all this. Back to orchestrators and the sad world of having to wait for data to complete. Dagster is also hoping to help solve a little bit of that. What we've seen a lot with traditional orchestrators is you often don't have visibility into what's happening in the transformation layer, right? If you think of your traditional Airflow sort of model of the world, as you have a task 1, a task 2, and a task 3, and you don't really know what's going on in 1, 2, and 3. You just know you have to run these things. But the actual thing you care about is like some data asset, some table, some model, and you don't know where that comes from often, right? There's no like way to fully understand that. And sometimes you might just have to run everything in order to refresh one table. You're often like manually stitching these things together as well. And so you typically don't have this nice integration between the orchestration and the transformation. So if you're using Airflow in a tool like DBT, you just call DBT and you hope it's done. And then once it's finished, you get the results of that, but you're not really clear onto what's working or not. So what you really end up with is like this world where things are just kind of disjointed and they don't really work well together, right? There's not a clear handoff between the orchestration side of things and the transformation side of things. And you live in these kind of two disparate worlds where nothing's really connected. And you really get just poor data quality out of it, right? Because you don't really have clear line of sight in your orchestrator, which is kind of where you are supposedly observing this entire data platform that you have, but you don't really get to drill down into the underlying thing you're building. And so there's problems with data quality. You also get, increased cost, operational complexity gets higher and higher. Like I said, you can't really build and compose these things because they just rely on these like obtuse tasks that sort of run, and you sort of assume that they'll have to just complete in order to get the thing done. Whereas if you work in a sort of asset-centric world that DBT or that Dagster provides, is you start to get really granular details on the underlying things you actually care about. And so you have one particular table you're interested in, you can click on that, you can view that, you can search for that in the catalog. And then you can, materialize just that one, or you can set, fine-grained controls on that certain asset that you care about. So you have some stakeholders that care about having this particular table be up to date once a day, but you have some other table that drives some operational process needs to be updated once an hour. you can do all that within Dagster because you have this observability onto the asset layer. So that's sort of the power of Dagster. And if we think about Dagster and SDF together, we really can start to think about how like they really enrich each other. So I think I'll give it to Lucas to talk about this.
Yeah. Yeah. So mentioned kind of at the beginning that there's this offline world and this online world, right? Offline world is you're writing some code, you're changing some configuration, changing table schemas, creating a new model, whatever it is. And then you have this online world, which is the orchestration where you want something to run on a cadence. And keeping those two worlds in sync, that's really been the core challenge. And what we've done as part of this integration is take a lot of the metadata that SDF generates at compile time, right, to make sure that the offline world is correct, and hand those guarantees to Dagster or integrate SDF into Dagster to provide those same guarantees and more metadata at the orchestration layer side. And the result is, yeah, you have more robust pipelines, lower execution costs, and I think a much better developer experience. So we're really, really excited. I think this is, call it data harmony maybe. But what you want is the transformation layer and the orchestration layer working together. And ultimately providing the thing that you want locally, which is great development experience and great testing experience. And on the orchestration side, easier observability and control, and the ability to intelligently drive down costs and automate more of that cost savings with caching and reducing the amount of the DAG space that you actually have to execute. So that sort of sums it up on the presentation side of things. I think it's time to get into a demo. And what we will go over is an introductory SDF workspace. We're going to be using our Mom's Flower Shop workspace, which contains the basics of an SDF project, including classifiers, multiple environments, some SQL statements. Again, everything is going to be running locally here directly on my machine. We're going to scaffold a Dagster project with a SDF workspace, and then materialize assets using the built-in SDF transformation engine, SDF execution engine, SDFDB. Once we have those things working, we'll create some changes to models, maybe even some breaking changes, and kind of see what the development experience is like. And hopefully show you, a really clean integration between transformation and orchestration, and hopefully the future of data development. So that's it for the demo. Pedram, unless you have anything else, I will do the screen share switching, and we'll get into some code.
Let's do it.
Cool. Also, I had a very loud leaf blower in the background. I hope that didn't come through too loud. Cool. Let me pause the video, stop the screen sharing here. We'll get out of this, and it's time to get into some code. Cool. All right, we're doing the riskiest thing in Zoom. We're going to do a whole screen share. And on the left half of my screen, you should see a VS Code editor. And this VS Code editor has, minimize these folks here. This VS Code editor has Mom's Flower Shop completed. We have a SDF workspace with some include paths. We are including some models, some seeds. Seeds here are just Parquet files. Our models are in Medallion architecture. We have raw, staging, and analytics. I think in total, right around 12 models. And on those models, we will add some things like classifiers. So we have some column classifiers like an in-app and a marketing event, some PI information, table classifiers like retention. And again, keep in mind, SDF really works with those classifiers natively. You can attach classifiers to tables and columns to track things like retention, like sensitive information, not just at a single table, but SDF will actually propagate those classifiers downstream. And Dagster gets to take advantage of all of this intelligence so you can actually see those classifiers directly in the Dagster UI as well. Additionally, we have some metadata for all of our tables and things like checks and reports, which are sort of SDF unique data quality features. We won't be going into them in any detail for now. So maybe before we get started with the Dagster scaffold, let me clear this, and we will do an SDF compile and to make sure that our warehouse compiles successfully here. If we want to look at all the table schemas, we can do SDF compile and show all. And now we can see that all the various sort of table and transformation information that SDF has as part of this workspace. So let's scaffold Dagster. We already have a virtual environment here, the DG demo. There is a pip install for Dagster SDF. And we will share some code after the call so that if you want to try this out for yourself, you can absolutely do so. So Dagster SDF is the new Dagster and SDF integration. We're going to scaffold this workspace. I'm going to create a new Dagster project here, and we'll call it Mom's Flower Shop Dagster. And it's initialized. It was that easy. So Mom's Flower Shop Dagster here has all the Dagster information that we need. Most important here is assets. Assets contains things like the output directory, the current environment that we're going to be working with. We'll use the default DBG environment, and crucially, the SDF assets. And what you'll see here is that the SDF assets are yielded from running SDF and saving the information schema. What does this mean? SDF internally generates a very rich information schema that contains not just table schemas, or not just column information, but full-on table schemas, including type information, upstream lineage, downstream lineage, column level lineage, a whole bunch of information. And we can take that information and hand it to the Dagster engine. And that's exactly what we're going to be doing here. So we'll go into Mom's Flower Shop. We will run this Dagster dev command. Note the environment flag that we're setting here is that we are going to compile on load. What that means is that we want to as soon as we load Dagster, compile the workspace and make sure that everything is in a green state. We'll run this, and we see the Dagster daemon starting. You can see in the logs here that we are compiling once again. We have the application open on port 3000. Let's open port 3000, and here we go. Mom's Flower Shop Dagster. A bunch of assets that have never been materialized. Maybe we can view lineage, and let's dive into some of the cool stuff that we already have integrated. So here's the workspace. We can go to something like ag installs and campaigns and see a bunch of metadata, including, for example, three-part name. SDF will always output three-part names because of its dynamic renaming, so there's no more ref statements in the orchestrator. You always get three-part names. And you have things like the full-on table schema. So you already have, without ever materializing, a complete understanding of every table schema and all the metadata for tables. So it includes descriptions, but it also includes things like, in the customer case, things like PII, right? All the classifier information that SDF understands, Dagster now understands as well. And from this sort of single pane of glass viewpoint that you really want your orchestration layer to be, I think, or we think that's a really sort of fantastic benefit that you get with these two things. So let's do some materializing, and let's materialize all. So now we're using SDF as the execution engine to materialize all of the assets. We materialized everything correctly, and if we actually scroll up in the Dagster daemon output, we can see the results of the execution. In this case, it's the first 10 rows of everything that has been run, right? So we the installs and campaigns, first 10 rows, and so on and so forth. You can note that this was all quite quick. The execution duration here was 0.023 seconds because SDF is fast, Dagster is fast, and we didn't even have to do any network calls because we get to operate on all data locally without having to spin up any other processes, Docker containers, or make network calls. Next up, I want to point out that we're also not materializing from cache. I think this is maybe one of the absolute highlight features. Typically, you have to run or understand what part of the DAG that you want to run. With the SDF and Dagster integration, SDF now talks to Dagster and says, hey, we only have to materialize or rematerialize certain components of the DAG. So if we rematerialize all, we do check to make sure that everything is rematerialized. But internally, we actually understand and have state saved so that we know that we only have to, or that we don't have to rematerialize some of these tables. So you can see now that the execution duration actually went down from the already fast 0.023 seconds to like 0.005, which I think is sort of the lower bound of how long it takes to spin up and execute a job. And from a developer standpoint, most of the time you're not actually building a whole DAG, right? You only are changing a single model at a time. So let's do that. Let's change just a single model and make sure that this caching feature actually works. So let's go to models. Let's go to analytics, change something in ag campaigns here. We had this extra line. We don't need a second platform row. We just changed this SQL file. We can run SDF compile again here, make sure that everything compiles correctly. And if we go to our Dagster UI and we rematerialize all, you'll see that the execution is once again quite fast, and that only ag campaigns ends up being materialized, not from the cache. So you'll see that the runtime here is a little bit longer because once again, we had to rebuild this component. But raw customers, for example, was materialized from cache, and the runtime is dropped down from 0.008 down to this faster time of 0.005. And this is true for DAGs of arbitrary sizes, right? So if you're changing a DAG with 10,000 nodes and you're only changing a single model, a single leaf node at the very end, everything stays cached and materializations are super, super fast because nothing is actually or most of the DAG is not actually changing. Great. So on the Dagster side, we now have more metadata information. We have cached DAG runs, and we can use SDF as a built-in execution engine. So if you want to do some mild transformation in Dagster, you can do that directly with SDF as well. Great. On the development side, if you introduce an error now, so let's say we take platform 2, which is a column that doesn't exist, or you create a syntax error, SDF will catch that directly in development without that error ever actually making it to the orchestration layer. You can run the SDF compile, and SDF will catch that error because the column does not exist. And this goes for all valid, in this case, Trino SQL, but for Snowflake SQL and other types of SQL as well. Cool. I will, I believe, pause the demo here. and see if there's any questions, any other things that you wanted to add, Colton or Pedram. Colton, I know you've been working closely with Alex here on the integration side, or if there's anything else that you wanted to sort of point out in this demo.
Did you cover making a boo-boo when you're typing?
Uh, yeah. So let's see what actually happens here. So let's say we created this new column like platform 2, or Pedram. Is there any type of boo-boo that you wanted to make?
Yeah, let's do a function that's not allowed on that particular type.
Platform 2 is
A string.
I believe platform 2 is a string. So
Sum it. Are you allowed
cool.
to sum strings? I don't think so, right?
I don't.
I
Let's
hope
find out. So if you compile, first SDF will tell you that
Right.
that platform 2 doesn't exist. So let's say you sum platform as platform sum. Let's see what SDF says at this point. And oh, great.
Nice. Whew.
SDF tells you, hey, sum requires a var sum received a varchar, but it can only take a big int, a double, or a decimal, or a real, or an interval. So from again, from like a development standpoint, SDF knows all the function definitions and will tell you when those definitions don't match, because in this case, platform is a type that you are not allowed to feed to some function.
And I think anyone who's written large amounts of SQL with many, many columns, and you are like 8 CTEs deep, will know the pain of this, because you send this over, it takes like 12 minutes for it to run. It finally hits the one like DAG you changed, the one model you changed. And then Snowflake will be like, one of your columns is bad. And it won't tell you which one too. So like this is really cool. Gives you the exact line where the problem happened. Just so nice.
Yeah. And if you use VS Code, SDF will always provide the file, the line, and the column. So you can actually, if you go to, I don't know, let's say you're working in raw addresses, but the error is here, you can always click on the error, and it will bring you exactly to where the error is.
That's so nice.
Yeah. And if you try and materialize, I mean, let's see what happens if we materialize this in Dagster. The Dagster run will fail, and it will actually provide you with very similar error output. So here's our run failing, and we can see exactly that this asset failed to materialize. Again, with in this case running it, but you can catch that same error directly on compile as well. So from like a CI/CD integration point, this is, I think, really great, because now you get to develop locally. You have full confidence that the pull request that you're making, the SQL that you've changed, is actually correct and will run almost deterministically when it's fed to Dagster. So I think determinism is like I know there's a lot of hype around AI, but determinism is like a beautiful thing in software systems. And I think this sort of integration between orchestration layer and transformation layer helps make data development more deterministic, and that is a good thing.
That's great. Do you have plans on integrating like an LSP, a language server, in here at some point?
It's almost like our roadmap.
It's like,
yeah.
Wait, why do I have to wait to type? You should just tell me.
Yeah, why do you have to type SDF compile to get
that's so many letters.
Yeah, that's yeah. So there's this if I think from a data development standpoint, like the best LSP for like Snowflake, you get in the actual Snowflake editor, again, because they have the compiler, right? Like a language server is built on the results of the compiler. The compiler says, hey, here's the problems, here's the potential options. So building a full-featured LSP is in large part dependent on having a really powerful compiler. I think we've spent the last couple of years building out the compiler part. Now we get to build the fun features on top, and that includes things like an LSP and potentially linter. We'll see what comes out next.
That's fun. Thank you.
Great. Um, cool. Maybe I can stop the screen sharing here unless I'm happy to jump back in if there's any particular features that folks want to see. Um, and I will stop the screen share, I suppose.
Yeah, I think we can jump to questions. We have a bunch, so maybe I can pull some in here. Some of them I think we've answered. So uh, maybe let's jump to this one. Do you have any plans on supporting Postgres? Looks like currently only data warehouse style like Snowflake are supported.
So sorry, I was reading through the questions. Can you
Oh yeah,
repeat
yeah.
one more time?
Do you have any plans on supporting a database like Postgres?
Yeah. Uh, we are really actively looking for development partners for other types of SQL dialects. Postgres is definitely one of them, as are things like Flink and so on and so forth. So the ones that we are compatible with at this point are Redshift, Snowflake, BigQuery, and Trino. But Postgres, Spark SQL, there's quite a few that are on the roadmap that we want to capture as well. I think we have the foundations down now. There's really this interesting question of like, how do we get enough different SQL queries to really validate that
Right.
SDF and the compiler are absolutely correct, that we've captured all the functions, because reverse engineering some of that actually is quite a bit of work.
There's a couple of questions here that I think we've answered through the caching. So let me just read them real quick for everyone. Brandon asks, a current limitation in Dagster DBT is that models represented as views have to be materialized to run complete asset pipelines. Does SDF provide a means around this, or is this a Dagster limitation? And Jeff asked a similar question. Let's say I have SDF DAG that is entirely views, nothing changed. When Dagster runs, will it recreate the views every time Dagster runs or not? And I think the answer is caching will solve this, right?
Yes, I believe the from my understanding, Alex is here, who built a lot of the integrations. He might even be better suited to answer this. But from my understanding, the caching layer keeps the state of tables and views. And as a result, if the view doesn't change, or the table doesn't change, or the function definition doesn't change, or the classifiers don't change, nothing changes in the DAG. As soon as things change that could impact the actual like runtime that has runtime implications, then SDF will invalidate the cache for that asset and rebuild.
Sweet. Uh, let's see. Oh, here's a good one. If everything is running locally, do you need a local sample of your data?
Yeah, so this was completely local with like Parquet files, but SDF you can authenticate with something like S3, and just like an object store DB, you can say, hey, grab me this, these Parquet files or these JSON files from S3, do the transformation theoretically in Dagster, and then save those results somewhere else. And that means that you get to work with local data like small seed files directly on the container. Or if you want to work with larger data sets or do some sort of like, ETLT process where you're pre-processing things, you can pull that data from some remote object store. Currently, SDF just supports S3, but we're looking at what other sort of object stores we might want to support in the future.
Got it. And what about something like you're in Snowflake? How does the local development work there?
In local development with Snowflake, so you just write the Snowflake SQL. And now there's this question of what's the actual state in the database, right? Like Snowflake has some schemas, and maybe those schemas are changing, but your code is still, whatever, from a commit from a week ago. How do we catch those errors and make sure that like the changes in the Snowflake database are actually captured at the transformation layer? The way that SDF works is, and this is sort of the part that we didn't show because it's not super relevant to the Dagster integration, but SDF connects to Snowflake and pulls all of the current schemas for all of the root tables, or the tables that SDF doesn't have definitions for in code. And if there's a root table that has a schema and a downstream table that depends on a slightly different schema, right, where there's some sort of mismatch, SDF will say, hey, there's a mismatch between the cloud schema, right, what's currently live on the database, and what you have in code. And this is how SDF really tries to make sure that everything that is in the cloud and everything that is in code are always in sync. And I think this is sort of a really, really core differentiator between SDF and something like DBT, because SDF really tries to read those schemas first and make sure that whatever you have in code is completely representative and compatible with what is actually happening in the cloud on Snowflake, for example.
Got it. That makes a lot of sense. And so when you're working locally, you're still working against the cloud. It's not like caching data locally, right?
That's correct. That's correct. We've actually seen some companies, and this is like everybody's data warehouse is different, as everybody here knows, I'm sure. We've seen companies who will actually create root table definitions from protobufers, right? So that they have in code already all schema definitions, and that they don't let anything in Snowflake that doesn't have an in-code schema definition. And then you can keep working totally locally, right? And you can say, hey,
cool.
Here's all my seed tables, here's some protobufers, some create table statements that we're generating from those protobufers. Everything is in Git. And then we have these absolutely incredible performance characteristics where you can compile SDF in I think tens of seconds for like thousands and thousands of tables because everything is run locally. It's just looking at dependencies, types, etc. on code rather than having to always like talk to the cloud database to get information.
That's cool.
Yeah, I don't know, Peter, have you seen anybody like do this?
No, I've never seen.
Okay. Yeah, I thought it was super cool. So larger companies typically,
Yeah.
like the larger the warehouse gets, the more you want determinism, and sort of code first paradigm. And so I don't know if it makes sense for everyone, but I thought it was a very, very cool thing.
I imagine they have a ton of analysts who are in the warehouse.
Yes, yeah, they have, I think quite a few analysts working on it.
Yeah, that's cool. All right. Maybe one more question before we take it away back to the slides. Let's see. What is the added value for local development coming from SDF and Data Fusion compared to something like SQL Mesh and DuckDB?
Yeah, so I think they're two slightly different approaches to the problem, the challenge at hand. So from my understanding, SQL Mesh is based on SQL Glot, which is a parser, it generates an AST, and then we walk that AST and understand things like column of lineage and so on and so forth. Those things are very, very similar to SDF. But I think at SDF, and part of the reason why development of this has taken quite a while, and why we haven't really made this public until a couple months now ago, is that SDF also does type bindings and validates schema level type information. And that differentiator is what lets us validate SQL rather than just read and try and understand SQL at a high level. Because we do type inference, right? Because we know that, hey, this column is a varchar and this function takes in these parameters, that is what lets us generate a fully fledged logical plan and execute that logical plan. So we're no longer operating at the string layer, and we're not operating at the AST layer. We're operating at a logical plan layer that is executable. And so rather than trying to translate, what are Snowflake SQL into DuckDB SQL and hoping that function definitions match and that subquery expressions match and so on and so forth, we actually really tried to generate a fully fledged logical plan and execute that SQL natively. So it's not a translation, it is understanding it. It's not translation, it's compilation, which are two, I think they seem similar at first,
Yeah.
but they're very, very different from a technical implementation standpoint.
That's really cool. Maybe let's just jump back to the slides, to the closing page there.
Let me get these things back.
And just a reminder to the chat, we are in Dagster deep dives as well. We'll be there after this talk. If you have any questions that didn't get answered, we'll try and get them answered there as well.
Here, so maybe super quickly to walk through what we just saw in the demo. We walked through the example SDF workspace. We saw some classifiers. We saw some checks and SQL models. We ran a bunch of stuff locally. We scaffolded our Dagster project. We created some errors, made some breaking changes, fixed those breaking changes. And that was hopefully exactly what we wanted to see out of this demo. We went through our Q&A, and I think that is primarily it. There is an SDF community and a Dagster deep dive Slack, both of which please join. And then there's a next Dagster deep dive on September 3rd. Pedram, I don't know if you want to talk about it. If there's anything you want to share there.
No, I think if you would just, it's going to be hard to click on that link. We'll share that link in the channel as well, so everyone has it.
Yeah, so we'll share both the, we'll also share the Git repository with this example and a little tutorial for how you can run through this stuff yourself. And hopefully experience some of the magic that comes from integrating the transformation layer and the orchestration layer a little bit more closely. Great. Cool.
All right.
We're a little bit early, but Pedram, any other closing thoughts?
No. Thanks for presenting. This was great. It's great to see how far you guys have come as well. I'm excited to use this, and thanks to everyone as well for joining. And we'll see you, I think, in a couple weeks.
Excellent.
All right. Thank you all.
Thanks a lot.